Five 60-watt light bulbs represent 4.5 kilowatt hours each day. Multiplied by the national average cost of electricity, you spend around 59 cents to light your home in a single day. Multiply that by 30 to discover that $17.55 of each month's energy bill goes toward those 5 light bulbs.
Electricity. Honey, we're broke.
In order to reduce the amount of light consumption and reduce the monthly cost of light in your home, we developed this prototype.
The physical setup of our Luminance controlled lamp prototype consists of a Raspberry Pi, which has 3 white LEDs, 1 red LED, and 1 blue LED. The white LEDs are connected in parallel to a PWM pin on the Pi, while the colored LEDs are connected to separate GPIO pins. The resistors for the LEDs are all 300 ohm, as this was on hand. Connected to the Raspberry Pi is an Arduino Uno. Connected to the PWM pins of the Uno is a photoresistor in parallel with a 10K ohm pull-up resistor.
The Arduino is constantly reading values from the photoresistor and sends averages of 400 values to the Raspberry Pi. The Raspberry Pi starts the communication every time the real-time clock minutes can be divided exactly by 3. The Raspberry Pi maps the value from 0 to 100, and this value is used to modify the brightness of the LED by using the pulse width modulation pin of the Raspberry Pi. If the value is close to 100, the LEDs will go off, and if the value is close to 0, the LEDs will go on, and vice versa. The software first searches for the saved alarm file. If the file exists, the program loads the alarm values and proceeds to the alarm creation. If the file does not exist, then it creates it. To create an alarm, the user is requested for hour in 24-hour format, minutes only divided exactly by 10, and the day. Next, the program is constantly looking for active alarms. When an alarm is triggered, the LEDs are set by default to on for 10 minutes. We first used an API to request the latitude and longitude of the Raspberry Pi's live location. Using these values, we requested weather data and recorded temperature, cloud percentage, weather detail description, and sunrise and sunset time. Finally, the 2 LEDs that are connected will turn on and off depending on the recorded temperature. If the temperature is over 30 degrees Celsius, both LEDs will turn on, and if the temperature is less than 10 degrees Celsius, both will turn off. Our model first does the alarm file search and creation portion of the project. After that, everything is synchronized by the real-time clock. If an alarm is activated, the LEDs are set to on for 10 minutes, but we still record photoresistor and weather data. The model requests serial data every minute that is divisible by 3. The weather data is requested every 10 minutes, every time the first digit of the minutes is 8, so 8, 18, 28, and so on. Every time the model reads data of any kind, they are sent to the ThinkSpeak, which is an IoT online platform. The platform has channels that simply plot the data in real time.
With all of these processes added together, a user would be awoken at a designated time and be provided with a visual indication of the weather. Additionally, the Luminance controlled lamp will adjust its brightness level throughout the day, reducing electricity usage and saving the user money.